a previous video, we talked about Uber's QueryGPT, which is a very interesting case of sequential agentic workflow that goes from natural language from the user that is asking about a certain query that they want to execute or generate first, and then translate it into a SQL command that you can send to whatever data source so you can get the data that you need or the data set that you want to be looking into. So from architecture perspective, the natural language ask from the user comes in, which is, let's say, how many employees do we have in a certain, and the idea is this first flows into an agent called intent agent. This intent agent will be responsible for looking into what is the business domain or workspace that this natural language query is all about. And of course, in our example, it looks like we need to talk about employees in departments, and that's the business domain. After that, it goes to tables agent. This tables agent, depending on what the intent agent identified and the prompt from the user, now it understands what kind of tables that I'm going to depend on to actually generate this query. And then after that, there's another one called the columns agent, and the idea here to optimize. So you can see that from the tables agent, I already have the tables I can query, and I can just do a select star and just go crazy. But imagine if this prompt is asking for so much or a big data set, then I need to optimize where I make sure only the columns that I need come back. So the columns agent, it's part of the mission, which is to identify which columns are the only ones needed for this. And of course, after that comes in the SQL agent. Now with the flow of what the business domain or workspace is, I have the right tables, I have the right columns that I need. Now I can generate the SQL needed, and I'm going to come back in this case. Now, in my example, I try to demo this with LangGraph.js. So I tried to actually just add another agent right here that takes the SQL agent's result and executes it. So in other words, whatever goes back to the user instead of just the SQL statement, it's going to be actually the result that is needed. So now it's full circle, doing everything that it needs for the user in one shot. And now we're going to explore this from code perspective. I have it open sourced, by the way, and I'm going to provide the link in the video, but we're going to go through it together. GitHub right here, I have the repo, also visualizing how it's going to work. Again, just like we visualized it right now, there's the intent agent that its only responsibility is to get the specific business domain or workspaces, returning the tables involved, then return only columns needed. That's for the columns agent. SQL agent generates the SQL query, and then the execution validates SQL and run in SQLite. So for this project, just like as a demo, we use the SQLite 3 version of Microsoft's Northwind database, and I have the link for the open source, but those are the tables. Mainly it's orders, some aggregated tables for sales, territories, suppliers, employees. So there's a bunch of tables that is going to give us the same interaction that is needed for the agents to actually do the work. I use GPT-4o for all the agents, but the idea is just, again, to simulate what QueryGPT should be doing. And definitely once you find that the agent can do its job in a very good way, maybe with a local LLM, maybe with an open source one, or something cheaper than GPT-4o, then yeah, please, that makes sense. So it's going to be an optimization on your side. So of course, at the beginning, from LangGrapJS or LangGraph-like using Python, but on our side, LangGrapJS, there's the index file that's going to show that it's going to be run sequentially in this case, where the intent agent, tables, columns, SQL agent, and execution agent are running one by one, being passed the results from one to another. Now, if you don't like that and you want it to be a graph, but again, since QueryGPT is mainly sequential, your choice. So I actually have a graph one also that can serve the same purpose, where we have a state graph where we identify each agent, add them as nodes, and then start adding the edges. So between the intent tables, columns, etc. And then once it's done, we compile and we invoke, so this whole flow can execute at the same time. So it's pretty easy to run. So we're going to take a look at the agents. But before that, let's take a look at the tools. The whole idea of this is that each agent that we run, which is mainly, some of them are React agents. In other words, like they have the tools, they're weaponized with the tools to take action. So the tools that we have here are SQLite, which mainly is a query that I have that describes all the tables that are in the schema as to grab those information. And mainly it's used by the tables agent. And I have a SQLite query, which maybe those could be consolidated, but just for the sake of separating the tools for now. But SQLite query, what it does, like it just gets past the query and that query is going to be executed, and we're going to need that for the SQL execution agent. We have a tables one. This one, I actually have it hard-coded where it shows the workspaces or the business domain saying this is customers and sales insights, and these are the tables under it. Orders and shipping, those are the ones under it. Product management, employee and territories. Now, one way you can do that is actually grab the workspaces or business domains and then query the tables, throw them all to an LLM separate call by itself, and grab it so it can actually synthesize this kind of information that you can feed to the agent. Your call, I think it complicates it a little bit, but again, it's a matter of how much you want to make it fully detailed and more advanced. The workspaces, same thing. It's a simple tool that just returns the business domains. And that's for the intent agent that needs this information. Just once it sees the prompt from the user, it can say, okay, here's the prompt from the user. My tool can give me all the workspaces that I need. Then I'm going to compare and say, okay, this sounds like employee and territories, just like in our examples of how many employees in a certain department. Now, this is for the tools, data. Now, for the agents, that's the beauty of LangGrapJS, which it's a pretty simple implementation where you define the model that you want to use, which again, the brain of your agent, and then you create a React agent. I'm sure there is a different ways of doing this, but again, React, it's powerful because it has access to tools. So the idea here for the intent agent, as we said, is that the model is there and the tools is the tool that grabs the workspaces or the business domains for it, the prompt provided so it can actually do the work. And you can, of course, like in the prompt, I can specify which kind of format I wanted to return it in. And in the case of the graph that we are trying to build, this is all is being sent into the state graph. So that state is being shared between all these nodes. Going by one, so it's the intent, and then the tables, same thing, model, the tables tool that grabs the tables, and then the query, and then we have the column pruner. We tell it right here, remove any extra columns not needed using the tool, call it for each table to get the columns for each table, return only the chosen columns only. I may be like overemphasizing right here, but I wanted to make sure it's not returning but whatever columns that are needed for that format. And then, of course, the SQL agent. This one doesn't have a tool because whatever information it grabbed already in the context is enough for it to say, okay, and the LLM itself definitely is trained on a lot of SQL documentation, format as a declarative language. So that's enough for us to actually generate a SQL statement depending on the tables and the columns that were generated from the previous agents. Again, we said that it's running sequentially. So at some point, the SQL agent has all the information in the state to go next. So in this case, it generates the query. And finally is the execution one, which has the trigger. The trigger is a tool that is a SQLite query. So whatever SQL statement coming from that SQL agent is going to come here to the execution agent, and it's going to make sure it's validated first. There's no syntax errors. There's no issues. And then trigger the tool and return the results and turn it into JSON and return it. And that's mainly the implementation for the QueryGPT on LangGrapJS. Please check out the GitHub repo. Let us know if there's any feedback. I just wanted to have a small implementation kit that people can work with instead of just theory. Thank you so much.
For Robbie Innovations.